Welcome to Homework Lib.
Hi, so how's it going? So over here, what we want to do is perform the calculations of the electric field with potential that is given by the expression over here on the left, in this expression. So what we are going to have is that the electric field at this point is going to depend on the potential because we know that the electric field is equal to minus the difference of potential divided by the distance. Notice that the potential at the point 0, 0, 0 is going to be equal to 0. So the change of potential is going to be directly the potential at the coordinate minus 0, so the potential at the coordinate. So the potential at this point is going to be equal to A, which is going to have a value of 5 volt per cube meter times 1.5 meters squared times 0.4 meters minus my B constant, which is 8 volt over cubic meter, times 1.5 times 0.4 squared. So the potential at this point is going to be equal to 2.58 volts directly. So the difference of potential at this point, what it's going to generate is, if we put this on a current system, where the point corresponds to x equal to 1.5 and y equal to 0.4. To know the electric field, we need to know the distance from the origin that we're considering as our 0 point, and that distance is going to be directly applying Pythagoras' theorem to this result. So this distance d would be equal to the square root of 1.5 squared plus 0.4 squared, and this is going to be in meters. So this is going to be 1.55, well, 1.520, 1.5524 meters. So that means that the electric field would be equal to minus the potential, 2.58 volt, divided by 1.5524 meters. So the result would be minus 1.662 volt per meter. So now consider that this is going to be the value of the electric field, of the magnitude of the electric field, 662 volts per meter. And now we want to know what is going to be its direction. So in this case, the direction is going to be according to the angle that we have here with respect to the origin, and that angle is going to be found easily by Pythagoras' theorem. So that angle theta is going to be equal to arc tangent of the opposite cathode, which corresponds to this distance, 0.4, divided by the adjacent cathode, 1.5, which is 14.93 degrees. And with that, it would be all. Thank you very much and have a good one.